Welcome to the Low-Carb MD podcast. No one is beyond help. No one is beyond hope.
As we have always said, we are bringing you medical information and cutting-edge science, but none of this is medical advice. Please seek out input from your own doctor. Welcome to the Low Carb MD podcast. It is just me today. Dr. Brian Lenskis could not make it. His daughter got married, so he's out doing better things. But I actually get the pleasure of interviewing and talking with just an amazing researcher. This is Dr. Philip Prins. He's the associate professor and chair of exercise science at Grove City College. He did his Ph.D. in exercise physiology at the University of Pittsburgh. He did his master's and his bachelor's in kinesiology and exercise science at Georgia Southern. And he's been working for the last several years with many people who we've had here on this podcast, including Dr. Tim Noakes, Dr. Dom D'Agostino, Dr. Andrew Kutnick, and many others. And his main area of focus is diet and macronutrient partitioning as it relates to exercise performance, something that I've been very vocal and sort of passionate about. So honored to have you here. Happy that you're stooping down, you're coming down from the ivory tower to us lowly clinical folks and sharing all your wisdom. You know, we appreciate you coming.
Yeah. Thanks for the introduction. Appreciate it. No ivory tower over here.
So let's go back because I'm always curious, and before we get to some of the latest research that you've put out, which has been fascinating, just a little teaser. We've seen some of the highest VO2 max in low carb athletes I think ever published in the literature. But let's walk back, right? Let's walk back. So what made you clearly? You graduated with your bachelor's in kinesiology in 2009, your master's in 2011. Mm-hmm. So there was probably years of you being passionate about this space, right? Sort of before that. So help me understand what brought you to get educated in the manner you did to eventually get your PhD, and then what brought you to this field?
Yeah, so I'm actually originally from Cape Town, South Africa. I grew up there, and I was always involved in sports. So, growing up, played a variety of different sports: tennis, cricket, rugby. Did swimming, did cross country. So all kinds of sports. Always been very interested in anything sports related, sports performance, etc. I excelled in tennis. So I played on the local circuit in South Africa, built my way up, ended up being top 10 in tennis player in South Africa. So that's as far as athletic achievements goes, that's probably it. And then played a little bit on professional tour in South Africa, and then after that, the trend then and also now, right? If you want to go pro, we want to continue with tennis. It was to come over to the States. And so I had a couple of buddies who came over to the States, tennis scholarship, and, hope from there is maybe you can do something with your tennis career, maybe play professional. So that was the original goal or plan coming over to the States is getting a tennis scholarship and maybe even going professional. I was just, most of my younger days was just tennis, and everything focused towards, training and being as best as, possible athlete I could be. And so, that's how I came over to the States, and I played Division I tennis at Georgia Southern University. At the same time, they told me I had to choose a degree to study for. So I ended up choosing exercise science. I just couldn't see myself studying anything else. But to be honest, my original passion was more so sports related, not so much academia. And so as I started taking more exercise science courses, I became more interested. I also minored in nutrition. More nutrition classes I took, the more interested I got in the field. So I graduated, and I just wanted to learn more. And Georgia Southern University had a master's program, so I decided to do my master's in exercise science and took more nutrition courses. And by then, my kind of my tennis career was pretty much over, and I now was more kind of on the academia route. And while I was doing my master's, I got exposed to some teaching and research, and that got me into that field. And I went to the University of Pittsburgh and got my Ph.D. in exercise physiology, like you mentioned. And again, just there was always a passion and interest for nutrition. Even though I didn't do my master's thesis on that, my master's thesis was looking at indicators of fatigue in collegiate women's tennis players. But then for my PhD, I actually wanted to continue that, but then it got sidetracked and things happened where I couldn't do that. And so I ended up doing my doctoral dissertation looking at dietary supplementation. So actually, my doctoral dissertation was the shorthand of it was, "Does Red Bull give you wings?" So so that's kind of what got me interested in the nutrition space. And over the years, most of my research has focused on various forms of dietary supplementation, and then I transitioned over to the nutrition space, specifically the low carb community, and that's mainly Tim's doing. So Professor Tim Noakes from South Africa. So growing up, he's a highly influential figure, obviously, in South Africa. He's also from Cape Town. So he's just very well known, in the community. And I actually went to go see him when I was, I think it was about 14, 15 years old. I had some cramping problems as a tennis player, and I went to go see him. I forgot what advice he gave me, but I knew him back then, or just briefly. I remember I was thinking it was like 2010 while Tim was going through the whole court case that he went through for sending some silly tweet or that somebody found offensive, right? So it was during that time, I think, when Tim was making his transition to promoting more low carb diets. And I remember speaking to my parents. My parents were asking me about what's my opinion on what Tim is saying. And back then, right? So you have to understand this is many years of indoctrination into if you're exercise science, and also obviously you took as many nutrition courses that I did, you just get one side of the picture, right? And I think you're familiar probably with that. And so obviously now Tim came out low carb, so I was like, well, that doesn't sound right. Nobody at any of the institutions I attended ever said anything good about low carbohydrate diets, right? It's just high carb diets. That's what optimizes sports performance. Low carb diets, that just impairs your performance, and obviously gives you heart disease and makes you fat and all that stuff, right? So that's what 10 years of higher education got me. But that it did pique my interest that Tim did say that, because obviously I had a lot of respect for Tim, and that kind of made me dig a little bit deeper. And obviously, like a lot of people in this space, kind of had that moment in their life where they were like, oh my gosh, there's this huge amount of research that I was not exposed to. And I started talking about it in the classes that I teach. People started to look at me a little funny. Again, that's probably that's like 2011 or 12, something like that. Event reached out to Tim. Tim spoke a couple of times at our exercise science symposium here, so we connected. And that eventually got me to start again. This must be like 7 years or 8 years ago, I forgot now, where I wanted to do a study specifically looking at the effect of low carbohydrate diets on sports performance. So as you know, especially back then, I mean, it's not much really has changed that much, but especially back then, there wasn't a lot of studies on that topic, right? It's this dogmatic view, obviously, that carbohydrates are essential for sports performance. That's a dogmatic view within exercise science and sports nutrition. And there, up to that point in time, right, there really wasn't there wasn't many well-controlled studies specifically comparing low carb diets to high carb diets on sports performance. So I sat down and was like, well, let's do one. Let's do a proper one and see what's going on here. And so I developed that study. Tim joined in, and he helped with the design of that study as well. I think we did most of the data collection. That was probably in 2018, and then the study was published in 2019. That was the first study, and that was looking at the effect of. You might be familiar with that one.
Right, that was the 5K run. Right?
Exactly.
Yeah, in recreational athletes, if I remember right.
Exactly. So that's really the story. Somebody wanted to kind of know the background of that, how that got me into this space.
So let's talk about it, because I think well, let's talk a little bit about the findings of that study.
Yeah.
Okay, maybe the population that you looked at and what you found, and let's review that. So I think that was an interesting study. It was like you did, what was it, like 6 weeks of a low carb diet, right? If I remember, something like that.
Yeah, exactly. So as you might already know, and be familiar with that. Again, a lot of the previous studies on this topic, there's a lot of limitations to the studies showing, right, that the low carb diet is impairing sports performance. I mean, the adaptation period to the diet is usually anywhere from a couple of days to maybe a couple of weeks, maybe 3 weeks.
Well, can we talk about that before we talk about your study?
Yeah,
Because
sure.
I want to hear your thoughts about, you're a researcher in this field, and you design trials specifically related to performance. What is adaptation to you, right? Can you describe it? And then
Sure.
tell me how you as a scientist would verify if somebody is adapted or not. And maybe we can compare the scientific approach with maybe a clinical approach.
Exactly. So, I mean, people are going to have different definitions of that, right? So how, and I know, well, obviously within the low carb community, people are going to have different opinions about, all right, so what is fat adaptation, right? What's keto adaptation? Where do you draw the line? And our previous study, or the one we were just talking about, the one about the 5K, did provide some answers to that, because we looked at, the nice thing about that study is we looked at performance, well, not just performance, but a bunch of other stuff at frequent intervals, right? So, it's not just pre and post. We did testing on day 4, 14, 28, and 42. So when you do testing so frequently, right, you can then compare. So let's look at 5K performance, basically here initially, the first couple of days in. And then how does that compare? So basically every 2 weeks, you're doing another 5K. So 2 weeks later, so performance is what now? Is it better, the worse? Is it the same? 2 weeks after that, 2 weeks after that. So by looking at that, by doing testing so frequently, yes, it's a ginormous pain in the butt from a research standpoint. And that's why people don't do that, right? It's much easier to do pre and post. But if you do it so frequently, then you look at the time course of these adaptations. And so, sure, when you look at that study, you'll see that the 5K performance on the low carb diet was impaired initially. So, that first session, after the first couple of days, it was about day 4 of being on the diet, their 5K performance was significantly slower on the low carb diet compared to the high carb diet. I think the difference was like it's like close to 50 seconds. Right. So if 5K, well, that's 50 seconds, that's
a big deal. That's like that's a huge difference.
Sure. I mean, it's almost a minute.
Yeah.
Right. So I mean, so I think a lot of people, right, in the low carb community, right, or who've read up on this space, or who have tried the diet themselves, right, report kind of, right, they can see impairments in performance, right, as they make that switch, right, as they're going from the high carb diet to the low carb diet. But from a research standpoint, what we're looking for, right, for any of these studies, we want to make sure people are compliant. We want to make sure people are adapted, right, to a certain extent, right? How do you define that? So sure, you can measure blood ketones, which we did in that study. The participants on a low carb diet measure their blood ketones every day throughout the 42-day intervention period. On that study, their blood ketones average about 0.5 millimoles. So they're in a state of nutritional ketosis. Sure, over the 42 days, great, fantastic. But also, if you look at the metabolic characteristics measured during the actual test, that's an excellent way of also seeing, well, the people are becoming adapted. So we perform VO2 max testing or graded exercise testing. When you do that test, you can measure, say, the peak rate of fat oxidation, but also during the 5K. So 5Ks as well, again, we use the metabolic cards that, again, if you've ever done a test like this before, you have the mask on and you're measuring your O2 and CO2, and from that you can calculate substrate metabolism, right? Carbohydrate metabolism, fat metabolism. And so what you want to see is on the low carb diet, right? So we want to see that, significant increase in fat oxidation. And and that's what we saw. So that from our standpoint, right? So we can see the athletes, right? The participants are becoming fat adapted, right? Because not just their blood ketones are becoming elevated, they're in a state of nutritional ketosis. Sure, from a dietary standpoint, we can see we're tracking that. They're consuming less than 50 grams per day. Fantastic. Oh, look, they're during the VO2 max or the graded exercise test. And also in these repetitive 5Ks, we're seeing it's taking place, right? We're seeing reductions in the respiratory exchange ratio. We're seeing increases in fat oxidation. And so because we did it so frequently, we noticed that. And we saw kind of that continual improvement. And so it's interesting. It seems these metabolic adaptations happen pretty quickly. It happens very rapidly. Even at day 4, it was like, whoa, there's already significant adaptations. But there's definitely fine tuning that goes on down the road. So because their 5K performance was impaired, right, in the first couple of days of the diet. But day 14, 2 weeks later, there was no significant difference between a low carb and a high carb diet. However, if you look at the mean difference, right, so the mean difference went from about 50 seconds down to, I think it was about 30 seconds. So no, that's not statistically, right, if you look at the p-values and all that stuff, but you go, 30 seconds, they're still 30 seconds slower. Then 2 weeks after that, it was day 28. There was a change. Now, again, no significant difference in performance, but they were running it, I think it was about 5 seconds now faster on the low carb compared to the high carb diet. And then the last day, day 42, again, no significant difference in performance, but now it was 12 seconds faster. So it's very interesting. But with each 5K, basically every 2 weeks, they got better. They got faster, right? And so what we know from previous studies, even going back to Stephen Phinney, right, is that, that's from 1980s, that, there's at least 4 weeks is needed, right, for some kind of adaptation to take place, no impairment in performance to take place. And then clearly some fine tuning in metabolism continues to take place after that.
So, I want to talk a little bit about this for a second. So you're talking about measuring fat oxidation.
Mm-hmm.
You're talking about measuring performance, right? Okay. So, but certainly, there was a lot of individual responses. I think you had like 12 or 15 sort of people doing these 5Ks, and there were different individual responses. I often wonder how we can actually biochemically ascertain. And I've thought for a long time, maybe we should use uric acid. Maybe we should use uric acid to say if somebody is fat adapted or not. And hear me out, right? So you make ketones, you're making fat oxidation, what's the peak? Like 10 days? By 10 days, you're not getting any higher, right, with fat oxidation? Or is that wrong?
Our study, it was already 4 days, and Lewisburg already 5 days. People already, their fat oxidation is already, pretty high.
Okay, so fat oxidation peaks out, let's say a week, right?
Yeah.
Okay, and then, but your body is increasing ketone productions still during that time.
Sure.
Right?
Yeah.
And how can we measure if the tissues are using ketones for fuel efficiently? I don't think we have a way of measuring that, but we do have a surrogate marker to that, which would be uric acid. And so one of the ways and we track uric acid in our clinic, and we certainly see by about 2 months that uric acid levels drop and ketones are still high and leveled out. And I wonder if that's a marker of increased ketone utilization. And if
Yes.
it's used
So
kind of,
yeah, I don't have a lot of experience with that. It seems you guys are tracking that. We haven't done it in our studies, but I mean, you raise a good point, right? What what biomarkers, right, can you utilize? All right. I mean, obviously, some are more applied, where you can obviously just how are you doing, right? So you can I mean, when you're training, your performance, is it going up, is it going down, etc. Right? So what is your own perception of effort? What's your affect, right? But then sure, biomarkers, and these days there's so many different biomarkers available, and like I just mentioned, I mean, like in our study, I mean, you can track blood ketones, you can track, I mean, if you're able to, right, fat oxidation, I mean, that's helpful. But more, I mean, there's not I think an exact clear answer to that question, as we said previously. Like, people define this differently.
yeah.
Like, what exactly, like when are you fat adapted, right? So we did 6 weeks, but as I just mentioned, as we went through the results, it looks like these guys were getting better with each 5K. So what happens at 12 weeks?
Right. Well, let's talk about that, right? I think now we have a little more data, right? So what happens at 12 weeks? So, okay, so this was in 2019. And what was the critical feedback that you got? I'm sure, because this stands in contrast to, let's say, Louis Burke, who's,
Sure.
been critical of low carb approaches. Is this, are these, like, give me a sense of how fast these athletes were, because we know Louis Burke looks at elite sort of race walkers and
Yeah,
so
the old race walkers.
yeah. So, but help me understand, these recreational athletes, like what was, give us an idea of their, sports performance.
Yeah, I mean, so they were, competitive recreational runners. I mean, we usually, for a lot of these studies, I mean, you always try to get the best athletes you can. Now, kudos to Louise Burke, right? That she has athletes, that she has access to, elite athletes. And so if you look at those studies, right, it's the race walkers. So a lot of that data has been published on race walkers. I mean, it's tough. I mean,
But these were like 20-minute 5Ks. These aren't slow people.
yeah. So sure, if you want to go, yeah. So for our study, no, it's not right, elite, right?
But they're like top 2% compared to the general
exactly.
population.
Yeah. So I mean, I had one guy, he qualified twice for the Olympic trials. So does that count, right? I mean, he was doing his 5K in about 15 minutes. You have to understand, this is not like, oh, you go outside and there's a nice course. This is you're on the treadmill, right? Because it's a lab environment. You want to control. You have your sure, you have the heart rate monitor on. You have the face mask and the tube coming from it. It's not exactly the most comfortable setting to be in, right? And sure, most people in that study did it anywhere, if you want to range between about 15 minutes and 20 minutes. And so
we're talking about the top 2% of the population to about the top 0.01% of the population.
Well, sure. I mean, that's if 5Ks. I mean, if you can get to 20 minutes or sub 20 minutes, I mean, kudos to you. I mean, I think that's pretty respectable. Now, we actually did a calculation. So for that study, for our subjects, based on their 5K time, let's say about 20 minutes, they should be able to do a full marathon, a 26.2-mile race, in about 3 hours and 18 minutes. Now, I know some of them, and they do it a lot faster than that, but well, whatever. So if you look at that time, that makes them faster. If you look at the marathon statistics in the US, that makes them faster than about 90% than all other marathon finishers in the US. So the point from that study was that these guys, right, so the high carbohydrate diet did not improve their performance, or put another way, the low carbohydrate diet did not impair their performance. So if these guys, who are better than at least 90% of other athletes, if they weren't able to benefit, therefore it stands to reason, right, then the vast majority of other athletes and recreational athletes might not be able to benefit as well. But then people go, oh, well, that other 10%, what about them? Maybe they're special.
Well, no, I'm going to push back. That 5K time of 15 minutes is a 0.01%. This is a 0.01% time, and a 5K time of 20 minutes is a top 2 or 3% of all 5K sort of runners.
Yeah.
So these are not sort of average athletes.
No, I won't say that. No.
Yeah, but they're not, elite sort of Olympic level. As an average, as a group, they're not. But this is like performing at a very high level.
Yes, for sure, and that's why, if you read that paper, I mean, we think the results are very applicable and meaningful for, again, most, not necessarily, again, as you were saying, all athletes. I would love to do a study on elite athletes, right? With proper adaptation period and just all the controls, etc. Because the other thing, if people read our studies, we try to I try to be as meticulous as possible because that's my nature. We actually control for calories, and we control for body composition, and we control for training load. So just an FYI, the results that you see in our studies are diet induced, right? Because if you control for all those other things, ultimately the findings, whatever your findings, those are, you can say, well, those are diet induced findings.
Well, so I wanted to ask you about that because I found it odd that they didn't lose weight. I was looking at I remember looking at it. I was like, how did these people, these sort of athletes who probably have no appetite, now they have ketones, they're probably appetite inhibited. How did you get them to stay at the same weight? I mean, I'd imagine they, and I'm curious if there was any, caloric differences, now.
No, yeah.
Yeah.
Yeah, I mean, if you look at the couple papers we published on that topic, I mean, the total caloric intake, or at least the way we measured it, right, which is it's not gold standard, right? It's not a metabolic board study or something like that, right? You're people are tracking their macros, MyFitnessPal, on a then they're working with a dietitian on staff, et cetera. But sure, whenever they come in, right, we measure their body composition, and and obviously you're talking about individual differences, right? Some people gain a little weight, some people lose a little weight more than others, but yeah, there's no statistical significant difference in body composition. Sure, if you look at the means, you go, oh, well, the low carb group, right? The mean difference is a little bit more, right? But again, these people are, it's important to understand they are pretty lean individuals.
Yeah.
Right. So I mean, they're just very athletic. They're very lean. They don't have much, body fat to lose in any case. So it's really not that surprising that there's really no difference in body composition in these studies. So it's different, like the work that you guys do, right? Or obviously you go look at the clinical stuff, right? Overweight, obese, then you'll find the differences. But in these studies, everybody starts so lean.
Yeah, well, one of the criticisms that I know that's sort of been leveraged out. So I think it was Paoli's work who looked at, I don't know what it was, the elite gymnasts.
Yeah, it was gymnasts. Yeah.
They argued that maybe it was, the body composition improvement that, showed his results, and but in this case there was no difference. Yes, this is amazing work. I mean, basically, what you've shown is at the least 99% of people can adopt a low carbohydrate diet without any impairment. I shouldn't say that. With the expectation of impairment in the short term, but over the long term, no difference in impairment.
Yeah, and then the other really interesting thing is looking at this from a metabolic perspective. So if I can quickly touch on that, because again, that was really interesting, because it's not. Yeah, most people are interested just in, flat out, tell me if I'm getting better or faster, right? But if you look at, because again, while they were doing this, right, we're doing using the Metcard indirect calorimetry, we're measuring a bunch of stuff at the same time. So it's very interesting that when they were on the high carbohydrate diet, so running the 5K, they're running the 5K. Anybody who's done a 5K before, that's a high intensity, short duration endurance event, and you're not going for an afternoon stroll in the park. You're going fast, and they were running it at just over 80% of their VO2 max, right? So that's high intensity. Okay. So what is the traditional thought that if you do high intensity exercise, we say, right, within the exercise sciences or sports nutrition, right, that's a carbohydrate dependent, form of exercise because the intensity is so high. Right? We can talk, later if we have time, whatever, about the, crossover concept and stuff like that. But
You're talking about the latest study, right?
yeah, you open any exercise science textbook and I have
high
one,
intensity is 50% glycolytic, or whatever.
have one right here, right? You turn the page, right, and the old crossover concept,
Yeah.
right there. And I think any exercise science student, right, is familiar with that. So it's saying, well, as the exercise intensity increases, your rate of fat oxidation goes down, rate of carbohydrate oxidation goes up. And it's saying at that intensity, right, if you look at these graphs, it's at that intensity, 80% of your VO2 max, the percent energy coming from fat oxidation should be like 0, right? So it's basically, exclusively you're burning carbohydrates for fuel. That's where the energy is coming from.
And in that study, it was like 85% or something like that, right? Like 80%, that 5K.
Yeah, so for the 5K, they were going at 82% on average, right? So 82% VO2 max. So the idea is, right, so their performance...
The latest study went even higher.
Yeah, even higher. We can talk about that also, next, but we're saying their performance is going to be impaired because the low-carb diet is reducing your rates of carbohydrate oxidation, right? Because when you go on the diet, your rate of fat oxidation goes up, but your rate of carbohydrate oxidation also goes down. And so that's all these other studies published over the course of the last, couple of years, right? That's saying the low-carb diet is impairing sports performance. What's the justification? Well, the justification is that the low-carb diet is decreasing your rates of carbohydrate oxidation, therefore impairing performance, because we know those high-intensity exercises is so-called carbohydrate dependent. It's dependent upon high rates of carbohydrate oxidation. So this was very interesting, right? So we're saying, well, can fat substitute for carbohydrate at these high intensities without impairing performance, right? That's the hypothesis is, right, does high rates of fat oxidation induced by a low-carb diet impair high-intensity exercise performance as performed above, right, that crossover point, which for most people is occurring at about 60% of their VO2 max. Okay. So very interestingly, when they were on a high-carb diet, now we just make a quick note, these studies that we've done, it's crossover design. That means each participant does each intervention. So it's not, for example, like a parallel group design where you have, okay, well, these guys are low carb and these guys are high carb. The crossover design is each person that you see in this study did both interventions. So
you're measuring their ability to adapt to the diet and
yeah,
back and forth.
Exactly. So, and that's interesting, right? Because you're looking at the same person did both diets, right? So in any case, when they were on a high carb diet, running the 5K at that intensity, 94% of their energy expenditure came from carbohydrate oxidation, which means only 6%, right, came from fat oxidation. Okay. So what happened when they were on the low carb diet? 65% of their energy expenditure came from carbohydrate oxidation, which means 35%, a big number, came from fat oxidation. So what happened when they were on a low carb diet, right? Their rate of carbohydrate oxidation dropped from 94% down to 65%, but then their fat oxidation increased from 9% up to 35% without impairing their performance, right? And it's commonly argued in this field that low carb diets, right, impairs also your metabolic, what's known as your metabolic flexibility, right? But our experiment shows just the opposite, right? If you think about it, when they were on the high carbohydrate diet, athletes showed an almost complete dependence on carbohydrate. It was almost exclusively carbohydrate, right? Very high rates of carbohydrate oxidation. But when they switched over, athletes retained the capacity to utilize both carbohydrate and fat at high rates at these high exercise intensities without impairing their performance. So we think that's pretty significant.
So help me understand this, because if you look at Coca-Cola and Gatorade sponsored exercise science literature, and
Sure.
people who are hell-bent on saying that the nail in the coffin for low-carb diets is already been done, right?
Yeah.
It's help me understand, what are they missing? What are they missing, and are we looking at two different things? Because the nature of these types of work is short term. Is the problem here that it's short term, or is there sort of an agenda and people have a thing to prove? Because I really looked at sort of Louise Burke's work, and I'm, not to criticize her, she's an amazing scientist,
Mhm.
and I can't help but think, like, why wouldn't you extend the trial? Why wouldn't you
Mhm.
supplement, certain minerals? Like, I just
Yeah.
thought to myself that, like, it's such a waste.
Mhm.
The other part of me, which suspects that many, I've written about bias against ketogenic diets. I've written a letter to the editor against Chris Gardner and on some of his work, because I feel like there's a strong bias
Mhm.
against these types of diets. And I wonder,
Yeah.
is it bias? Is it being myopic? Are we all on different things? How is it that we see so differently than convention? How can that be? Are they just focusing on that sort of 3 week, whatever it is, and they have no sort of thinking beyond that point? Or
Yeah, I'm not sure what the thinking is behind that. That's why I said when I started this field, I wanted to do the research, properly, meticulously. I wanted to control for as many other aspects of as possible, and I think that's what makes our studies kind of stick out. Because if you don't if it's not a control trial, it's not a randomized control trial, and if you're not controlling for all these other things, and the adaptation period is not long enough, right? Because again, if you talk about limitations, again, there's at least three that immediately come to my mind. If you look at all these other studies, number one is the complete absence of studies specifically designed to refute the hypothesis. They design their study. It's a lot of people in this field design the studies with, well, here's the outcome, right? This is the finding I'm going after. Now I'm going to design it to get that finding. No, that's not how you do it.
that's exactly how I felt about the trial design in her latest publication. I felt like, and again with Gardner and his work with Diet Fits and his keto med study, I felt like they were brilliant trial designists for the outcomes they wanted.
Yeah. Yeah. So that's definitely part of it, right? How you design your the study and what's your hypothesis. So we set up our study specifically designed to refute the hypothesis, which is, well, does high rates of fat oxidation, right, which is obviously induced by a low carb diet, impair exercise performance, especially higher intensity exercise performance? So that's one. Number two is obviously the adaptation period to the diet. We talked about that. Most of these studies, couple days, couple weeks, that's shorter than the 4 weeks or more that's been shown to be more optimal. And then the other interesting point is a lot of the studies, the key studies actually published in the scientific literature in support of this so-called carbohydrate dependence of high intensity exercise, well, they only look at athletes who are adapted and habitually consuming a high carb diet. And why is that important? Because the habitual diet very strongly influences the metabolic response to exercise.
Yeah, so the other part of it is, I thought, well, what is the likelihood? So we know, if you look at the diet adherence literature, that diet adherence is less than 3% of the population, right? They intend to hold a diet, and less than 3% will actually be able to maintain that diet over the long term. And if you look at the athletic sort of mantra, the sports related nutrition advice that's always been promoting carbohydrates. So you've narrowed the pool down, to less than like 1% of people who are in this sort of an athlete, can adhere to a diet, wants to adhere to a diet, and is able to. So what if we just never study this properly? I just wondered, is that the reason why we maybe see things differently than some of our conventional counterparts in the exercise science?
Well, sure.
They've never seen these people,
That could definitely be a part of it as well. Yeah, I think the other big part that people have to understand, like, why is there not a lot of studies in this space, is because the dogmatic view that it's existed for almost half a century, right? That carbohydrates are essential and preferred fuel source for athletes. Like, I mean, that's what I was taught. I mean, that's 10 years of education, higher education right there. And that's I mean, what you do is you have your textbook, and then people teach directly out of the textbook written by people, and then you just repeat, right? So then you learn something, and then you repeat it to somebody else, and they repeat it to somebody else, and that's pretty much what's happened right over the course of the last 50 years. And that's obviously not just the case in the sports nutrition realm, but also other areas as well. And so I mean, that's just what's happened. It's almost like people just gave up. I was like, what's the point in studying low carb diets and sports performance? We know it's going to impair performance. And how are you going to get a grant? Like, where you going? You're going to go to what, DOD, NIH, ask for, I need a couple of $1,000 or whatever to study this topic, and people are going to laugh at you. So it's a waste of money. We already know it's going to negatively impact performance. So that's definitely a part of it. Probably a big part of it.
Let's talk about that. Let's talk about that a little bit, because I think that this is important. But that there's a lot of sort of interest to involved, but yet you've been able to sort of get funding, find like-minded scientists. I mean, some of your latest work over the past 2-3 years, and I think you've put out 4 or 5 studies in the past couple of years, and they've been, in my opinion, very groundbreaking. So how do you reconcile, and maybe we can talk about some of the newer studies that you put out, and then also, help me reconcile, because there are some interventional studies, yes, in carb laden diet sort of habituators, right?
Yeah.
That carbohydrates, if the intensity is high and the load is high, that carbohydrates may have some benefit, right? And what are the mechanisms that there is a body of literature that has that shows periodizing carbohydrates could be of benefit. Certainly,
sure, yeah.
I would say under 30 minutes of training, there's almost no benefit. Maybe over 1 hour of intense training, and particularly over that, there's probably some data to support carb periodization. So, I think Tim has hypothesized that it could just be preventing hypoglycemia as its mechanism. So what are your thoughts on the data that exists and the data that you've come up with? And then if you can just describe the data that you've seen over the past 2 years and the several publications you guys have put out.
Yeah, so sure. We're not dismissing, I think that's an important point that you bring up. I'm not dismissing like all this research over the last 50 years showing, right, that carbohydrates is improving performance. Like that, we're not saying, oh, that's not right. I mean, that's a a good body of literature, showing ergogenic effects of carbohydrate supplementation. So that's not what that's not what we were going after. We were just saying, well, what if that approach is compared to a diametrically opposed approach? What if you eat completely different? Can you still have the same performance, or is it as everybody has been saying, is it actually worse? Right, and we've shown now in a couple different studies, and we'll talk about the newer studies here in a little bit. We've shown that, hey, it's the same. Now, sure, there's also always individual responses. We know that, but if you look at the results of our studies, it's the same. So performance is the same, and it's not just our stuff. You go look. Well, there's actually over the course of the last couple of years, I know 2021 there was a meta-analysis by Murphy, and then there was another one. I think McSwiney, or I've botched his name. I don't know, but there was another. There's been I think there's been 2 meta-analyses that have come to the same conclusion, and I have it somewhere here in my, in my notes. One of the meta-analysis, I think it was by Murphy and colleagues. It's titled "High-Fat Ketogenic Diets and Physical Performance: Systematic Review," and just for this one meta-analysis, again published in 2021, 17 studies, 29 performance outcomes. So of those, 13 was endurance type performance outcomes. Of those 13 endurance performance outcomes, 10 reported no difference between the low carb and the control diet, which is obviously the high carb diet. And then when you look at the power or strength outcomes, there were 16 of those, 11 reported no difference. So you can see the vast majority of studies, right, is actually reporting no difference, right, between the lower and high carbohydrate diet approach. So therefore, the overall evidence suggests that physical performance can be maintained on a low carbohydrate, right, or ketogenic diet. Now, does more need to be done, for sure, but I'm just letting people know it's not just, the Prins, here at the Grove City, exercise science lab finding these findings. Other people have found the same thing, and it will be, valuable if other people can also jump on the boat and also do, some of these studies.
You mentioned Sweeney, you mentioned Powley, we talked about Powley. They've
Sure, yeah.
Luke Ciprian had an interesting study as well. I mean, it seems to be at least some small pockets of
there. Exactly. There is, you can find a small handful of studies out there. And sure, when you look at those studies, I mean, they're showing that physical performance again can be maintained on the low carbohydrate approach.
Yeah, so let's switch gears a little bit. Well, before we do that, I'm going to ask you a quick question. I'm going to put you on the spot, so we'll take a little break from all the academia. Okay. Do you think that, and I just need the short, sweet answer, train low and perform low, or train low and periodize carbohydrates for your 5K? Let's take it that way. If you had to guess an outcome, right? So like, your athletes trained low and performed low, right?
Yeah.
That's what you were measuring. What if they periodized carbohydrates right before their
Yeah, I think there's something to that. I think there might be something to that behind this concept. Again, which does that need to be studied a lot more? Yes.
Yeah.
I mean, that's just something people have written about or talked about, but it was a very interesting. I mean, I can talk. One of the guys in our study, he was on a low carb diet, and he was busy finishing the low carb diet, and a very good runner, and he was running Boston, and he always wanted to do sub 3 hours for Boston, and so he just finished the low carb diet, and he only had a couple days before it was like 2 or 3 days before Boston, and then he went back to the high carb diet, and he texted me after the race, and he ran his fastest race. So is there something to that, where for that study was the 4 weeks or 31 days, where he experienced a lot of metabolic adaptations and obviously increasing fat oxidation, et cetera, during that 4 weeks, and right before the race, increases carbohydrate intake. Is there something to that? We are actually not designing, we're actually starting a study right now. I don't want to say too much about it, but it looks at this idea of, hitting the wall phenomenon. So that, and this, sure, being in a low carb state, but ingesting carbohydrates also during the event. But here's, I think, where other people have gotten it wrong. I mean, maybe we find this, maybe we don't, I don't know. But if you go look at the literature, like how much carbohydrate you consume during exercise, it's a lot, right? You go look at the ACSM recommendations, it's a lot. Like,
you mean the ACSM that took money from Gatorade and Coca-Cola? ACSM?
Yes. So it's like 60 grams, 100 grams, sometimes 120 grams per hour. I mean, it's a lot. So what we're saying, it's not what's the most you can consume, what is the least you can consume? And that's what part of our study is going to be about. I think people will realize, you only need a very small amount of carbohydrate or glucose that needs to be consumed during exercise for, as you mentioned previously, what Tim said, for the maintenance of blood glucose during exercise, right? Because I mean, in this, so if you're going, why am I bonking or hitting the wall? Well, it's either, right, the idea is either, my muscle glycogen stores are running low. That's the prevailing view, right? Your carbohydrate fuel tank, so to speak, is running on empty, or you're becoming hypoglycemic, right? So if it's more about hypoglycemia, right, so then it's only a little bit is needed, right, to sustain blood glucose levels for the person to basically keep on going. So again, I don't want to say too much because that's what our next study is kind of focusing on. But it's a very interesting topic, and I think to answer your question, I know you wanted like a one-word response, but I think there's benefits of training low, and then maybe compete high. Sure, but let's maybe redefine high.
Yeah, and figure out exactly what I can't wait to see that.
Maybe high is actually low.
Yeah, I mean, I cannot wait to see what you guys come up with. So let's segue into what you've been working on over the past couple of years, because you did some amazing work. I think one of the points that I've criticized the prevailing exercise science literature is that we really don't know the extent at which we don't know enough about low carb training low. We don't know enough about it.
Mm-hmm.
And some of the studies that you've put out, basically building upon what you've already studied, the 5K running times. You guys did a study, and I say you guys, Noakes, Volek, D'Agostino, Kutnik, looking at sort of crossing over, looking at using a keto bar for sort of sports performance. I mean, you guys have done a lot of cool stuff, and a shout out to, I have not endorsed by, but a shout out to the Keto Brick, which you guys used, and I love Keto Savage, I love them, which I think was at the bar you guys used there. Yeah. I have no sponsorship from them. Okay.
Yeah.
So you know what? Start with that study. So can you tell us about? Because I think we covered the 5K. I want to talk about the 5K, but start with that study, because I think it was just, we all know it, but it was interesting to see it.
Yeah. So sure, and you also bring up a good point about conflicts of interest. I would note that when you look at the research that we've published, number one, it's those studies that you're talking about. They're happening here on campus in our lab, and I don't have any conflicts of interest. So just so people know when they read our studies, sure, Dom and Tim and Volek and et cetera, they're all involved, and those guys have some affiliations, but I don't, and I think that's important to understand, because all the data collection, which is obviously that's the results. It's coming from here, and that's all internal. That's all internal grants. I'm not getting money from Gatorade or any of these, or whatever other company that's on the other side. It's actually the money to fund all these projects. So Grove City College is they have internal funding available, and that's where the money from all these projects has come from. So just a quick point about that. But yeah, so it's interesting. So we've been talking about some studies about that's more kind of like chronic adaptation, right? The previous one was 6 weeks, and then another one we did was 4 weeks. But interesting, you're talking about the Keto Brick study. That's acute, right? That's acute. So what we did is we compared the effects of a high carbohydrate, kind of, if you want to call it, an energy bar. It's the Cliff Bar. So I think most people are familiar with the Cliff Bar. You see it, at any grocery store, right?
Yeah, I tell my kids it's poison. So
there you go.
Jokingly say it's poison.
Yeah. So the old, Cliff Bar or the old sugar bar, and then like I was just showing you, right? Sure. Robert Sykes, right? He does the Keto Brick. And so we stumbled upon it, or Dom told me about it, and I was like, well, that's interesting. It's diametrically opposed. I mean, it's very low, it's very high in fat, very low in carbohydrates. So we're like, oh, this is interesting. Like, I bet you nobody has done a study on this before. And let's compare the traditional pre-exercise feeding strategy, which is carbohydrate, right? To something else, right? And let the something else be the Keto Brick. So what we basically did, and again, for that study was college students, but they are recreationally active, right? So obviously none of these kids are fat adapted, right? None of these kids are on a ketogenic or low carbohydrate diet. So, and it was like almost 30 of them. So we had a nice sample size, and what we did is, these participants would come in the morning in a fasted state, usually about 8 hours, and then they would have their breakfast. Breakfast number one, right? So this is 1,000 calories, right? So this is pretty nutrient dense. or 1,000 calories off the Cliff Bar. Now we had to do 4, because one Cliff Bar is not going to be 1,000 calories, so it's about 4 Cliff Bars, right? So it's obviously just more weight to get to that same amount of calories. So they would have their breakfast, one or the other, right? And it's a crossover design, and then we would wait 3 hours, right, for things to get digested and absorbed, etc. So then 3 hours after they've consumed their breakfast, they would do a time to exhaustion protocol. Well, it's a military ruck protocol. Basically, you take a backpack, you load it with weight. It's 30% of your body weight. Then you're on the treadmill. The speed is not that high. It's only like 2 or 3 miles per hour, but the incline is tough. It's about 14% incline.
That's
So again,
that's rigorous with a weighted. I mean,
yeah, it's not easy. So if you're going, well, it's the speed is low, sure, but I mean you're walking up a very steep hill or incline with a good amount of weight on your back. So I mean you definitely feel it for anybody who's done that kind of thing before. And sure, and we're looking at time to exhaustion, right? So this is basically right. Time to exhaustion trials is, well, how long can you go before you throw in the towel and say, forget this, I can't do this anymore. And obviously at the same time, we're measuring a whole bunch of physiological, perceptual, and metabolic stuff. But so again,
sorry, were these adapted? Just remind me. Sorry, were they adapted? Were they habituated to a low carb diet?
No, so that's the interesting point, right? These are just college kids, recreationally active, consuming standard American diet, fasting for 8 hours, coming in the morning, having their breakfast.
Okay.
Yeah.
Then waiting 3 hours. Then
yeah.
Okay. So basically, at that point, let's just hypothesize in the blood there's still triglycerides, free fatty acids, but at that point there's no glucose, there's no hyperglycemia. That's all shoved into the tissues. So their glycogen stores are replete.
Mm-hmm.
Okay.
Yeah. So I mean, again, you would just think that, well, their performance again should be worse or impaired on the keto break, right? Because now they're performing exercise, and again, what about their glycogen stores? And they're not going to be able to use as much carbohydrates, right, during the event. But when you go look at the results, time to exhaustion on average, it was close to an hour on both trials. It was like 55 minutes. And you go look at the means. It was no significant difference. Like I said, about 55 minutes or so on both conditions. And then, sure, there were some interesting metabolic shifts. Again, this is acute, which is why it was interesting. The keto break, or the high fat energy bar, increased fat oxidation, decreased carbohydrate oxidation, in compared to the Cliff Bar, where you saw higher rates of carbohydrate oxidation and lower rates of fat oxidation, without impairing performance.
Yeah. I mean, basically, fuel partitioning matters, right? That's and doesn't necessarily affect performance acutely.
Well, maybe macronutrient intake plays a much lesser role than what we think in terms of performance than has been previously thought. I know Tim published a paper on that, a big review paper, I think last year, on that topic, if people want to go read that up. But again, it's interesting when you think about it like that, right? Because now we've talked about some of the chronic studies, and even now this acute one, we're actually doing a follow-up to the keto break study. Instead of looking at time to exhaustion performance, we're looking at 5K performance. So another 5K study. That study is about half done. So I don't want to say too much, but from what we have already, I can just allude that doesn't look like there's any difference in performance either. So what's going on here, right? Why is performance acutely and chronically not impaired on a ketogenic intervention, low carb intervention, acutely or chronically? That's not what we've been told or taught.
Yeah, do you think this is mainly the result of interest, or it's just that our society has not been able to escape processed carbohydrates over the last 50 years?
I mean, it's definitely a combination of those factors, in addition to a lack of interest in studying these topics.
Yeah. Can you briefly sort of talk about which I think is a sort of landmark study in exercise science, at least in the low carb, at the least in the low carb space,
Yeah.
Talk about your, some of the what you found on the crossover study with regards to fuel partitioning and sort of fat oxidation.
Yeah. So again, like you said, I mean, we believe the work we've done is pretty novel and impactful, and actually, if you go back, there's a study by Krog and Lindhart, I think 1920, that started this idea that fat is an inferior metabolic fuel and able to support high intensity exercise. So we basically believe the stuff that we've done overthrows about 100 years of teaching within the field of exercise science and sports nutrition. And that's sure you talk about the crossover, but actually now I'm thinking about something else as you're talking about this. What was that quote by was it Albert Einstein, where he said something like, no amount of experimentation, right, can ever prove me right, but a single experiment can prove me wrong, right, at any time, or something like that. I think people need to go look at that quote. But so sure, so the whole crossover concept, again, that's another dogmatic, view within this field. And I just showed you earlier the picture in the textbook, right? So that goes back to Brooks and Mercier. They published that in 1985. But again, this whole idea that fat is an inferior metabolic fuel, you can at least trace it back to 1920, so just over 100 years ago. And basically, if you look at the crossover concept, right, it's basically, if you look at the x-axis, it's the exercise intensity, right? And then on the y-axis, you're looking at substrate metabolism, carbohydrate, and fat. So it's really not that hard to understand. What it's saying is, as the intensity is increasing, right, as you're going from left to right on the graph, your rate of fat oxidation is doing this. It's decreasing precipitously, and your rate of carbohydrate oxidation is increasing precipitously.
And you shifted that graph way, way over, basically, right?
Yeah, because it's saying the crossover point is occurring at about 55, 60%, right? So if you're saying, well, if you're the average person or athlete, if you were to do a test like that, and you say, well, your crossover point, it's occurring at 60% of your VO2 max. Okay, so what does that mean? That means at that point, that means 50% of the energy is coming from carbohydrate and fat, right? It's an equal split. But once you go above that crossover point, then the majority of the energy is coming from carbohydrate, right? Because if you look at that graph, it goes, carbohydrate oxidation does this. It shoots up and fat oxidation shoots down. So that figure implies, and those teachings imply, right, there's a specific exercise intensity where fat oxidation peaks. And once you go above that, you cannot increase your rate of fat oxidation anymore to sustain, the metabolic needs associated with exercise. But it's such an important point because this line of teaching and thinking is used as justification to teach people away from low-carb diets, especially for athletes who perform exercise above 60% of their VO2 max. And you go, well, hang on, isn't that like most athletes? Like, don't most athletes train or compete at least at 60% of their VO2 max or higher? That's moderate intensity. Of course they do. So if you want to know, like, why for the last 50 years, the vast majority of athletes, right, are being told to consume a high-carb diet, well, one of that has to do with glycogen, right? This glycogen-centric view of exercise performance. But the other big reason has to do with the crossover concept, right? So we're saying if you're performing more higher intensity exercise, it's not dependent upon high rates of fat oxidation. It's dependent upon high rates of carbohydrate oxidation, right? The so-called carbohydrate dependence of high intensity exercise. So what we did, actually, when we finished the one study looking at the 42-day 5K intervention, when we finished that, I was like, me and Tim, we sat and we're like, hang on, we have a complete data set here because we perform graded exercise testing. So like, we have a data set here we haven't really published or discussed in the scientific literature that looks at this relationship between exercise intensity and substrate metabolism. And then I went back and I looked at the data, and many painstaking hours later, we're able to do some calculations and make our own figures, right? To hopefully maybe one day substitute, or if not anything, not substitute, but maybe be published alongside the regular crossover figure that you see in the textbooks.
I want to see that. Did I see that figure? Which study was it in?
Well, so there's this paper over here that was published in Biology of Sport.
Oh, yeah, where you had that dotted line going down, right?
But then there's also a review paper that we published earlier this year in Frontiers in Physiology, looking specifically at low carb diets,
Cool.
crossover point, yada yada yada.
For the people listening, these will all be in the show notes, so we'll get them for you.
Yeah, and so basically, in short, what we found was, again, just very interesting. On the low carb, when they're on a low carbohydrate diet, the crossover point did not occur at 60% of their VO2 max. It occurred at 85% of their VO2 max. So, meaning at 85% of their VO2 max, right? That means 50-50 split between carbohydrate and fat. Only once they went above only once they went above 85% of their VO2 max, then only did carbohydrate oxidation go up and fat oxidation go down. So only above 85% VO2 max did carbohydrate start to make up the bigger share of the total energy contribution. So that's really interesting, because then we also did the same calculation for when they were on the high carb diet. So at 85% of VO2 max, that was the crossover point on the low carb diet. 50-50 split between carbohydrate and fat oxidation. So you go, well, what happened at 85% VO2 max on the high carb diet? Was it a 50-50 split? No,
It's like a 90.
It was 90%. It was like a 90-10% split, right? 90% of the energy came from carbohydrate oxidation, only 10 came from fat oxidation. So basically, what this shows is the so-called carbohydrate dependence of high-intensity exercise is just an artifact of the habitual diet that's been consumed prior to that. And that study that I just that I just showed you, I mean, if you think about it, that study by itself, which is basically a spin-off from the previous one, that study by itself disproved at least 3 commonly held beliefs and doctrines within the sports nutrition and exercise science field. Again, this belief that low-carb diet impairs your metabolic flexibility. No, it does not. We showed that it improves your metabolic flexibility. So think back to what I said in the 5K. What happened during the 5Ks? Athletes maintained the ability to oxidize both carbohydrates and fats at high rates during the 5K, right? When on a high carb diet, it was almost complete carbohydrate dependence, 94%. Then you look at the results from the VO2 max, right, trial, right? Well, it's the same thing. At these high intensities, even at 85% VO2 max, 50% of the energy is coming from fat. High carb diet at that same intensity, only 10% is coming from fat. So that's all evidence for not impaired, but improved metabolic flexibility on a low carbohydrate diet. So that was that was a big finding. And obviously the other finding is, again, you cannot substitute fat for carbohydrate without impairing your performance. Again, we've shown that during the VO2 max trial to be false, during the 5K time trials to be false. And then the newest study, the 1 mile time trials, the 800-meter sprints, or the interval sessions, right? In all those sessions, rate of fat oxidation was very high, and it did not impair exercise performance. So,
can I ask you a question? What was the reception from critics? I'm sure you heard a lot of people like myself and others sort of cheerlead what you found and what you've demonstrated. I'd imagine you probably face some critics in the field. So,
well, I'm not on social media that much, so I don't. I'm assuming a lot of the criticism these days comes from social media. So I'm sure people were saying bad things, and I just didn't see it. But I would say the study was published in 2019 on 5K. That, I think, for the most part, that was ignored. Right, inconvenient finding. But then some of our other work that has just been published this year, I think, people couldn't ignore it anymore. So I saw a lot more people engage with that study, and probably it's also because there's your big shots are on that paper, right? Tim and Volek and Dom, so it just gets a lot more attention. And from what I saw, I didn't see much criticism because the study was done. It was very well controlled. So what do you say? What's the criticism, right? So the criticism is usually just, oh well, it's not elite athletes. Like, okay, whatever, you go study elite athletes then. You can do what we did, just replicate it in elite athletes. So we've provided the foundation and the groundwork if somebody wants to go repeat it. And then sometimes people, or seen some people criticize the fact that on the low carb diet, their protein intake is a little bit higher.
But it was like a couple percent, right? It wasn't it was a nominal amount, right?
Yeah, I think in the previous study, because that's a hard one to control for too, right? Because I mean, obviously, if you're eating low carb, it's the types of foods you're consuming, right? Fat and protein go together, so that's a tough one to equate. But sure, so some people will say, well, they ate, say, 20 or 30 grams a day more of protein on the low carb diet. Well, does that really explain why their performance was the same? And I don't know, that's a little bit of a, I don't know about if you're gonna nitpicky that one point, and that's the reason why you found, or we found these findings. I don't know about that.
Got it. Well, it's just been this has been an absolute pleasure. I've learned so much, and it's exciting to know that you have a lot more coming. I just can't wait to sort of see it. It's when I started writing about low carb and athletics, I was really basically thinking about there was this was about 5 years ago, 2018, before sort of your body of research came in. And at the time, there were these small pockets of literature. I mentioned some of those people, Paoli and Cyprian McSweeney. And now, like, to bring more and more of this to literature, it's just I think there's at least a groundswell. I think what we really need is probably a conference on sort of low carb athletics. I think that would be an interesting, I'm part of the board at the SMHP. I think that would be kind of cool.
Yeah, that would be really interesting.
If we can get some people together, and I think it's a hot topic, and that's something we can do. And we'd love to, maybe if I do get that off the ground, you'll be the first person I call.
Awesome.
So
you make a great point that so anybody who's been in the space know that there's been an enormous body of work, and kudos to everybody, including yourself, who's done this work on like clinical populations, right? Diabetes, weight loss, et cetera, et cetera, et cetera. But something that's been neglected, unfortunately, is this space over here, looking at sports performance, right? Because like I said, people just gave up almost on it and just, just let's not even study it. So, I mean, yeah, so people, have done it and starting to do more of it. But I mean, my goodness, like if you were to look at this space and you go, well, do we need more studies looking at the effect of, say, low carb diets and sports performance? Well, yeah, I mean, a lot of the studies we just discussed was looking at running. I mean, what about all the other sports?
Well, there's some solid data. We talked about gymnasts. We talked about, there's some studies on HIIT training.
Soccer.
There's soccer. There's been CrossFit, some studies with CrossFit.
Yeah, CrossFit. Yeah.
Olympic weightlifting.
Yeah, some resistance training. Yeah.
So,
but yeah, just think about different sports. What about weight maintenance in athletes? What about immune function? What about recovery? What about injury risk? What about your hand-eye coordination? Like, what about tennis, golf, something like that? And what about females?
Yeah,
we haven't. Most of those studies is just a bunch of dudes, which is fine. But like how do females respond from a low-carb diet from a performance perspective? That would be really interesting too. So,
how do people support, like, how would they support you? So say they've seen the 4 or 5 studies you've put out in the past couple of years specifically on this topic.
Yeah.
Do they call Grove City and say, let me write you a check? Like, how does it work?
Well, sure. If that's also a great point. Because the studies we do, any of these studies are not cheap. And some, I'm sure there's generous people and companies who donate product. But yeah, I mean, any of these studies could be very expensive. So if I can send you a link to, I know Grove City College has a link that can take you specific to the exercise science department. And if you then want to give, you can then do so online. So you don't have to, call somebody and then go through 50 different people. Like you can just click on the link and that's going to take you specifically to our page. And then if you feel strongly about it, if you want to support the research, and I hope people, will do that. And then that's probably the best way to do that. So I can share that link with you.
And how do they get in contact with you? Let's say they're a researcher, they're somebody considering a project, they're looking to, come to you and be an intern in your lab if you have one. How do they reach you if you want them to reach you?
Yeah, for sure. I mean, people are always welcome to contact. I mean, my stuff is available, right? If you just Google, my name, I mean, you'll get to our institution's webpage, and then my email is right there. So it's just pjprins@gcc.edu. So you can always email. Sure, you can social media. I'm just gotta be honest, I'm not too great at keeping up with all that. You're much better, Tro. So
I have help. I certainly have help.
So that's probably the best ways, I think.
Awesome. Listen, I can't thank you enough, and I appreciate all the work you've done and sort of the vigilance. What you're doing is absolutely needed, and it helps us, right? Just think about the clinical translations. Those people who are like, well, I really want to go to the gym and I really want to go work out, and I don't want to. For us to be able to say, no, we know about this, Dr. Prins. Let me know that there's not going to be any change in your, for 99.5% of people, we can certainly say there's no change in impairment and performance. And to be able to say, hey, you can use, for energy, or if that's something you need, you can use a keto brick or, whatever other product it is.
Again, that's such an interesting point, because I know you probably run into people all the time. I know, I do, where the main reason why, especially if you talk about, if you look specifically more people who are recreationally active, I mean, you don't have to be an elite athlete, just a lot of people are competitive, right? I mean, they run. I mean, we have a whole bunch of, guys in a study we're just doing, they're very, they're triathletes. The people are serious about their events. And if you say, well, why don't you try low carb, give it a chance? So I don't want to impair my performance, right? So that's what most people are, the big reason, even to this day,
it's ingrained that, well, what don't I need energy? I feel low energy. I have to eat something.
Exactly.
Like, hey, actually we have the data and we can help you. And it's because of people like you that makes it easy for me to say, don't worry about it. Drop your carbs. You're going to be fine. In a couple of weeks, this is going to be history. And
I'm sure you talked about this when you had Andrew on, but now the big thing, and again, if you go look at our previous study, right, it's not, if we have shown, and we'll, obviously we'll continue to do research on this topic, but if your performance is the same on both dietary interventions, then the next obvious question is, what about the health and disease implications about your dietary choice? And so I go, implore people to go look at our work on that, because we've done a couple of studies looking at, kind of your cardiometabolic health and how that's altered. I'm sure Andrew touched on that.
Let's talk about it right now, because I think we'll bring this up. What it's alluding to is a substantial portion of even elite and sub-elite athletes have diabetic level blood sugars when they're habituated to a high carb diet. And so what he's saying is, forget about sort of the diet wars for a second. Now we have devices like CGMs and that can give you biofeedback. If you tolerate carbs and there's no issues, and maybe you don't need to change, but if you're going into those pre-diabetic levels of blood sugar, and even, elite and sub-elite athletes are doing that, you may want to consider what's the long-term impact of fueling that way. So what he's talking to is a huge body. Is this what you're sort of talking about?
Yeah, I mean, we've done a couple of studies just looking at different cardiometabolic markers, right? Your insulin, C-reactive protein, LDL, total cholesterol, HDL, VLDL, whatever. But then, the last study, we did that, but also did the CGM. And again, that's exactly what you were talking about. And if you go look at the previous review article, and Andrew got the data from a couple of studies that have done CGM and athletes, very interesting topic. I think there's only like 5 studies you could find on that. And I think 2 of them was ours. And it's like, holy moly, like, why are these individuals who are so physically active? So if you go look at our last study, And I can tell you those guys, right? They're not your average person. They're running a lot, they're biking a lot, they're swimming a lot. A lot of them are triathletes, clocking, many miles, 50, 100 miles per week. So, oh my gosh, like, why are they pre-diabetic? Why is 30% of them pre-diabetic? Why can't they outrun their diet, right? Because that's obviously the other mantra, right? Can you or can't you outrun your diet? So again, not everybody has to go ahead and switch over, but these individuals had no idea, right? Until they wore the device, the CGM, right? I mean, they had no idea that their blood glucose was, they were doing roller coaster. It was high during the day, it was high at night. I mean, so sure, that study, 30% of our sample, right, met that pre-diabetic glycemic phenotype. Even if you just look at the average blood glucose across the entire 31 days, across the, or circadian blood glucose, on a low carb diet, it was 85 milligrams per deciliter. And on the high carb diet, I mean, it was very close. I think if you round it up, it might be 100 milligrams per deciliter. So, you're playing with that border, right, of pre-diabetes. So, and now that, as you mentioned, as that technology becomes much more available, and the next study that we're doing, we're going to do the same thing, CGM, but that's going to be 6 weeks. I think more athletes will become aware of the impact that their dietary choice is having, right, on their overall cardiometabolic health.
And I think, again, empowerment is the key here. We have tools now that can sort of see individual responses. So I think we're in a very interesting era of precision nutrition, precision exercise. There'll be continuous lactate meters soon, which I think will be immensely useful.
Ketone, yeah.
Yeah, and so I think we're coming on an era of precision nutrition, and I can't express it as much. I think what you've absolutely done is demolish the concept that you need carbohydrates for metabolic flexibility. In fact, you need a CGM and a low-carb diet to probably be the most flexible, it sounds like.
Well, sure, the low-carb diet, right, provides a therapeutic strategy for people to manage their blood glucose, especially for those who are insulin resistant or pre-diabetic, without impairing their exercise performance.
Absolutely. Listen, all I can say is amen, amen, amen. And I appreciate all your work, and I hope other people listening to this get inspired to sort of follow in your footsteps and be, risk takers and examine some of these mantras, because, like you said, those graphs are 100 years old.
Yeah.
You just demolished them. So kudos to you.
Thank you.